Hello friends, welcome back to our channel Nursery to Varsity, and in this tutorial we will learn about diagonalization of a matrix. Now we will study diagonalization of a matrix. Before studying how to diagonalize a matrix, I will tell you some definitions which are necessary to understand before uh, forming a diagonal matrix from a square matrix. Similar matrices. I will tell you what are similar matrices. Let let A and B be two square matrices of order n cross n. Let A be a square matrix of order n cross n and B is another square matrix of same order n cross n. Then A is said to be similar to B. A is similar to B if there exists a non-singular matrix. A non-singular matrix T such that P inverse AP is equals to D. मैं फिर से रिपीट करके सिमिलर मैट्रिसेस क्या होती है? लेट A and B be two square matrices of order n cross n. Then A is said to be similar to B if there exists a non-singular matrix P such that P inverse AP is equals to D. Always remember, students, that we can find P inverse only and only if the matrix is non-singular matrix. Otherwise, we cannot find inverse of any matrix. So this is the definition of similar matrices. Now I will give you the definition of diagonalizable matrix. Diagonalizable matrix. A matrix A is said to be diagonal. Again, matrix A is a square matrix of order n cross n. A is said to be diagonalizable A is said to be diagonalizable if it is similar to a diagonal matrix. If it is similar to a diagonal matrix. That is there exists P of course, which is non-singular matrix, such that P inverse AP is equals to D, where D is diagonal matrix. So we have studied two definitions. First is similar matrices. If there are two matrices, square matrices of same order, then A is said to be similar to B if there exists a non-singular matrix P such that P inverse AP is equals to B. Then comes diagonalizable matrix. What is diagonalizable matrix? Again, a square matrix A of order n is said to be diagonalizable if it is similar to a diagonal matrix. And what does this mean? That there exists a non-singular matrix P such that P inverse AP is equals to D, where D is a diagonal matrix. Now I will tell you an important theorem related to diagonalization. And what is that theorem? The theorem says an n cross n matrix. Students, this is very important theorem. An n cross n matrix is diagonalizable if and only if it possesses n linearly independent eigenvectors. An n cross n matrix is diagonalizable if and only if it possesses n linearly independent eigenvectors. So I will give you a brief proof for this theorem. We have seen that it is if and only if, it means both ways implication. If there exists an n cross n matrix which is diagonalizable, then it possesses n linearly independent eigenvectors, and conversely, if any matrix possesses n linearly independent eigenvectors, then it is diagonalizable. Now suppose A is diagonalizable. A is diagonalizable. It means there exists P such that P is equals to x1, x2 up to xn, which is non-singular. Of course, P is invertible. P is non-singular, or we can say that P is invertible matrix, non-singular, such that P inverse AP is equals to D, where D is equals to diagonal matrix lambda 1, lambda 2 up to lambda n. Now, pre-multiplying both sides by P, pre-multiplying by P, we get P inverse AP is equals to PD. This implies AP is equals to PD, or we can write A into x1, x2 up to xn is equals to x1, x2 up to xn into lambda 1. Of course, lambda is the diagonal matrix. Lambda 1, lambda 2 up to lambda n. You can write here diagonal matrix lambda 1, lambda 2, lambda n. This can be written as ax1, ax2 up to axn. We can multiply inside, and this is equals to lambda 1 x1, lambda 2 x2, and so on, lambda n xn. Or we can write it here, ax1 is equals to lambda 1 x1 up to axn is equals to lambda n xn. Therefore, we can say that these are the characteristic equations of A. These are the characteristic equations of A. Therefore, x1, x2 up to xn are the eigenvectors. These are the eigenvectors, and diagonal matrix lambda 1, lambda 2, lambda n form the eigenvalues. This is the characteristic equation. This is the form of characteristic equation. Therefore, these are the eigenvectors and eigenvalues. Conversely, let A possess n linearly independent eigenvectors, say x is equals to x1, x2 up to xn, corresponding to eigenvalues corresponding to eigenvalues lambda 1, lambda 2 up to lambda n. Then by characteristic equation we know that ax1 is equals to lambda 1 x1 up to axn is equals to lambda n xn, or we can write it as AP is equals to A x1 x2 up to xn, where P is equals to x1 x2 up to xn, and this is equals to ax1 ax2 up to axn. This is equals to lambda 1 x1 lambda 2 x2 up to lambda n xn, and this is equals to x1 x2 up to xn into diagonal matrix lambda 1 lambda 2 up to lambda n, which is equals to PD. Now P is non-singular invertible matrix, so pre-multiplying both sides by P inverse, P inverse AP is equals to D. Hence we have proved that if A is a square matrix of order n and which is diagonalizable, then it possesses n linearly independent eigenvectors, and if it possesses n linearly independent eigenvectors, then it is diagonalizable matrix. Now I will take one question which will help you understand more about how to diagonalize a matrix. Now we will take one example to show how to find a matrix P such that P inverse AP is the diagonal matrix. So this is the matrix A. A is equals to minus 1, 1, 2, 0, minus 2, 1, and 0, 0, minus 2. This is A matrix. We have to find the matrix P such that P inverse AP is equals to D, the diagonal matrix. अब हम क्या करेंगे, सबसे पहले कैरेक्टरिस्टिक इक्वेशन फॉर्म करेंगे. डिटर्मिनेंट ऑफ A माइनस लैम्डा I is equals to 0. This is equals to determinant minus 1 minus lambda 1 2 0 minus 2 minus lambda 1 and 0 0 minus 3 minus lambda, and this is equals to 0. This gives minus 1 minus lambda minus 2 minus lambda into minus 3 minus lambda minus 0, and this is minus 1 into 0 and plus 2 into 0. This is equals to 0, and this implies lambda plus 1, lambda plus 2 and lambda plus 3 is equals to 0. तो यहाँ से lambda की वैल्यूज आती हैं. Lambda is equals to minus 1, minus 2 and minus 3. See friends, हमें पता है कि कैरेक्टरिस्टिक इक्वेशन जो है वो हमेशा एक पॉलिनोमियल देती है whose degree is same as the order of A. यहाँ A 3 क्रॉस 3 की मैट्रिक्स है, तो वी गेट अ पॉलिनोमियल ऑफ ऑर्डर 3, और उससे लैम्डा की 3 वैल्यूज आएंगी -1 -2 and -3. Now we will find the eigen vector. First, for eigen value lambda is equals to -1, we will find the eigen vector. So this is -1 minus -1, that is -1 plus 1, 1 2 0 minus 2 minus -1, that is -2 plus 1, 1 0 0 minus 3 plus 1. x1, x2, x3 is equals to 0. So we get 0, 1, 2, 0, minus 1, 1, 0, 0, minus 2, x1, x2, x3 is equals to 0. From this we get the equations. First equation will be x2 plus 2x3 is equals to 0. Second equation minus x2 plus x3 is equals to 0. And third equation minus 2x3 is equals to 0. This equation gives us x3 is equals to 0, and from first and second equation we get x2 is equals to x3 is equals to 0. So both x2 and x3 are 0, but we have not found what x1 is. So we can take x1 as any random value, that is, we can take x1 as k. So our eigenvector becomes k0, 0. Or we can write it as, if we put k is equals to 1, so this is 1, 0, 0. 1, 0, 0 is the eigenvector corresponding to the eigenvalue lambda is equals to minus 1. अब हम बाकी दो eigenvalues के लिए भी eigenvector निकालेंगे. Say for lambda is equals to minus 2, we get 1, 1, 2, 1, 1, 2, 0, 0, 1, and 0, 0, minus 1 into x1, x2, x3, and this is equals to 0. So from this we get x1 plus x2 plus 2x3 is equals to 0, x3 is equals to 0 from second equation, and minus x3 is equals to 0 from third equation. So we are getting x3 is equals to 0. Putting this value in first equation, we get x1 plus x2 is equals to 0, and x1 is equals to minus x2. If we take x2 as k, then x2 is equals to k, then x1 is equals to minus k. So eigenvector corresponding to lambda is equals to minus 2 will be minus k, k, and 0. If we take k as 1, then this will give minus 1, 1, and 0. This is the eigenvector corresponding to eigenvalue lambda is equals to minus 2. Now we will find the eigenvector corresponding to lambda is equals to minus 3. When we put lambda is equals to minus 3, our matrix becomes 2, 1, 2, 0, 1, 1, and 0, 0, 0 into x1, x2, x3 is equals to 0. So first equation becomes 2x1 plus x2 plus 2x3 is equals to 0. Second equation becomes x2 plus x3 is equals to 0. And third is 0, 0, 0 x1 plus 0 x2 plus 0 x3 is equals to 0. So from here, if we take x2 is equals to minus x3 and x3 is equals to k, then x2 is equals to minus k, and substituting these two values in first equation, we get 2x1 minus k plus 2k is equals to 0, 2x1 plus k is equals to 0, and x1 is equals to minus k by 2. So eigenvector corresponding to lambda is equals to minus 3 is minus k by 2, minus k, and k. So this is, if we take k as 2, then it becomes minus 1, minus 2, and 2. This is the eigenvector corresponding to lambda is equals to minus 3. So we can say our matrix P becomes P is the matrix of eigenvectors. It will become 1, 0, 0, minus 1, 1, 0, and minus 1, minus 2, and 2. So now when our P is this, I am again writing the value of P. P is equals to 1, 0, 0, minus 1, 1, 0, minus 1, minus 2, 2. ये हमारा P है. And we very well know that the matrix of eigenvectors, that is P, is the matrix which will change A to diagonal matrix after applying this transformation. P inverse AP is equals to D. तो अगर हम यहाँ पर P का इन्वर्स निकाल लें, और P इन्वर्स के लिए हम ये फॉर्मूला यूज कर सकते हैं, एडजॉइंट ऑफ P अपॉन डिटर्मिनेंट ऑफ P. फ्रेंड्स, मैंने ये फॉर्मूला आपसे पहले भी डिस्कस करा था इनवर्स ऑफ अ मैट्रिक्स के ट्यूटोरियल में. मैंने आपको बताया हाउ टू फाइंड द एडजॉइंट एंड देन डिटर्मिनेंट, एंड एडजॉइंट अपॉन डिटर्मिनेंट इज द इनवर्स ऑफ द मैट्रिक्स. So we can find P inverse using this formula, and when we apply the operation P inverse AP, then we will get D, where D is the diagonal matrix having diagonal elements as eigenvalues 0 lambda 2 0 and 0 0 lambda 3. इस केस में आपकी डायगोनल मैट्रिक्स D क्या आएगी? -1 0 0 0 -2 0 और 0 0 -3. फ्रेंड्स, आप इसको एक्सरसाइज की तरह भी देख सकते हैं. आई एम गिविंग यू एक्सरसाइज, फाइंड P इनवर्स एंड अप्लाई दिस ऑपरेशन P इनवर्स AP, और आपकी ये मैट्रिक्स आ जानी चाहिए. अगर ये मैट्रिक्स आ जाती है तो हमारा सारा जो हमने P निकाला है वो बिल्कुल सही है. ये हम वेरीफाई कर सकते हैं यूजिंग दिस ट्रांसफॉर्मेशन. सो दैट्स ऑल विद डायगोनलाइजेशन. मैंने आपको बताया हाउ टू फाइंड आइगन वैल्यू, आइगन वेक्टर, एंड हाउ टू डायगोनलाइज अ मैट्रिक्स यूजिंग द मैट्रिक्स ऑफ आइगन वेक्टर्स. I hope you like it. This is all for today's lecture. Hope you have enjoyed this tutorial, and if you have any queries, you can either comment in the comment box or mail us at nerdtovar@gmail.com. You can also follow us on Twitter, Facebook, LinkedIn, and Instagram. You can see the links here. And don't forget to press the bell icon to stay updated. Thanks for watching. Stay tuned.